From skyscrapers assembled in just days to entire parks created with 3D printing, from floating airports to AR technology transforming construction, China isn't just keeping up, it's racing ahead. These colossal projects aren't science fiction, they're happening right now. What you're about to see proves that when it comes to building the future, China is playing in the next century, while the rest of the world is still catching up. Huajiang Canyon Bridge, the world's highest and smartest bridge. The Huajiang Canyon Bridge in China's Guizhou province is about to break 2 world records at once. When finished, it will hang more than 2,000 feet above the canyon floor, making it the highest bridge on Earth. But this wasn't an easy dream to build. At that height, normal cranes and machines simply couldn't work. The steep cliffs, strong winds, and remote location made traditional construction impossible. So, engineers came up with a bold new idea: build the largest cable crane system ever made. Hanging between mountain peaks, these giant cranes could lift and move massive steel trusses, each weighing more than 21,000 tons, and place them with incredible precision. To make sure every piece fit perfectly, the team used advanced technology. They connected the system to the Beidou satellite navigation network and the Internet of Things, so every movement could be tracked and adjusted in real time. But height and strength weren't enough. The Huajiang Canyon Bridge will also be one of the smartest bridges in the world. Its main cables are filled with thousands of tiny sensors, like a nervous system, that constantly check for stress, temperature changes, or signs of damage. If something's wrong, the system can alert engineers immediately. When it opens, this bridge will not only be the tallest, it will be a symbol of human creativity, technology, and the daring to build the impossible. Mini Sky City, a skyscraper built in just 19 days. In 2015, China achieved something that left the world in disbelief. They built a skyscraper not in years, not even in months, but in only 19 days. The project, called Mini Sky City, became a stunning example of how fast and efficient modern construction can be. This 57-story tower, standing 670 feet tall, wasn't built the traditional way. Instead, it used modular construction, where each floor was prefabricated in a factory and then brought to the site ready to install, just like assembling massive Lego blocks. Once the pieces arrived, the building shot up at lightning speed, transforming the skyline in less than 3 weeks. But the story doesn't end there. The same company behind Mini Sky City has an even bolder plan: to build a 220-story skyscraper using the same method. If they pull it off, it will be more than 3 times taller than Mini Sky City and could set a record that might stand for decades. China's construction projects like this show that, for them, impossible is just another challenge waiting to be conquered. Hanli Shikumin Complex. When Chinese officials planned a new underground shopping center and subway in Shanghai, they faced a big problem. A historic landmark, the Hanli Shikumin Complex, stood right in the way. Demolishing it wasn't an option. So, they decided on something extraordinary. Engineers used a system of robotic jacks to lift the massive structure, which weighed a staggering 8,270 tons. But lifting it was only half the challenge. The jacks were programmed to walk, slowly shifting the entire building to a safe spot, step by mechanical step, almost like watching a giant take a slow stroll. Once the underground work was complete, the engineers did something even more incredible. They walked the building back to its original place, exactly where it had stood for decades. It wasn't just an engineering feat, it was a rescue mission for history, proving that even in the middle of rapid urban development, China can find ways to protect its past while building for the future. Boggler Power Station, the world's largest hydro-solar plant. High in Sichuan province, perched between 4,000 and 4,600 meters above sea level, nearly 1,000 meters higher than Lhasa, the Boggler Power Station stands as a daring testament to human ingenuity. This isn't just another hydroelectric plant or a big solar farm. It's the world's highest and largest hydro-solar hybrid power station. Spanning an area equivalent to 2,000 football fields, it packs 1 million kilowatts of power and delivers around 2 billion kilowatt-hours of clean energy annually, enough to power 700,000 homes for a year while saving over 600,000 tons of coal and cutting CO2 emissions by 1.6 million tons. Why combine two systems? Because solar power fluctuates with the weather. Water power fills in the gaps, offering reliable energy around the clock, especially vital for stabilizing China's grid. Built by Power China Chengdu Engineering and using Huawei's smart PV technology, the plant includes over 2 million solar panels, 527,000 foundation piles, their total length equivalent to 1,400 kilometers, and steel structures rivaling the Beijing Olympic Stadium's weight. 12 months of planning, 6 months of construction, and it's generating clean energy today. What's even cooler? The panels are raised 1.8 meters above ground to preserve local herding land, reduce evaporation, and even boost soil health, turning clean energy into local community gains. When complete, the Kela project will feed into the massive Yalong River clean energy base, aiming to power 100 million households annually and charting a bold course toward China's carbon-neutral future. Inflatable construction domes, building inside a bubble. China has come up with a clever way to tackle one of the biggest problems in construction, noise and dust pollution. Instead of relying on traditional methods that often fall short, some construction companies now enclose the entire worksite inside a massive inflatable air dome. This creates a fully sealed environment that muffles the roar of heavy machinery and stops dust and harmful airborne particles from spreading into surrounding areas. The trapped air is then filtered, ensuring that what escapes is clean and safe. With innovations like this, China isn't just building faster, it's building smarter and cleaner. And some of the incredible projects constructed under these giant bubbles are nothing short of groundbreaking. Fosun Foundation Cultural Center, a building that's never the same twice. The Fosun Foundation Cultural Center is more than just a theater, it's a living piece of architecture. Its design uses kinetic facades, moving exterior panels that slowly shift over time. The motion is so gradual you might not even notice it happening, but each time you glance at the building, it looks just a little different. Time-lapse videos reveal the true magic. Layers of panels drifting to create elegant, wave-like patterns that transform the building's appearance day and night. But this isn't just for show. The facades are also functional. Depending on the event, they can be adjusted to reveal or conceal the stage, offer sweeping views of the river to the east, or frame the urban skyline to the west. The result is a cultural landmark that's as dynamic as the performances it hosts, a structure that merges art, architecture, and engineering into something that's always in motion. AICT 3D Printed Park, a park made by machines. Imagine strolling through a park that looks like it came straight out of the future. Nearly 60,000 square feet of walkways, benches, flower beds, sculptures, and retaining walls, all created not by human hands, but by giant 3D printers. This is the AICT 3D Printed Park in Shenzhen, China, the first of its kind in the world. Instead of bricks, wood, or steel, the park's features were crafted layer by layer using a special form of concrete. The result? Smooth, flowing, almost organic shapes that seem to ripple like waves, blending seamlessly into the landscape. No two structures look alike, yet everything feels connected, as if the park itself grew naturally out of the ground. The real marvel lies in the speed and efficiency. What would have taken years using traditional methods was finished in just 2.5 months. The technology slashed labor costs, reduced material waste, and allowed engineers to design freely without the limitations of conventional construction. Beyond aesthetics, the project is a glimpse of the future. China isn't just experimenting with 3D printing, it's applying it on a massive scale. Parks today, but tomorrow. Entire neighborhoods, bridges, and even skyscrapers built this way. While much of the world is still treating 3D printing as a novelty, China is already living in that future. 3D printed pedestrian bridge, the world's largest of its kind. You might expect furniture or small objects to be 3D printed, but an entire bridge? In Shanghai, China, they've made that vision a reality. Stretching nearly 86 feet across a canal in Baoshan district, this striking pedestrian bridge holds the title of the world's largest 3D printed concrete bridge. What makes it so special isn't just the size, but the way it was built. Two massive robotic arms worked tirelessly for 450 hours, layer by layer, to produce the components. The finished bridge was then assembled from 44 hollow concrete segments for the main structure and 66 smaller segments for the handrails. This modular approach cut both cost and construction time compared to traditional methods. The design itself draws inspiration from ancient Chinese bridges while reimagining them through futuristic technology. Its flowing, wave-like railings aren't just visually stunning, they also highlight the freedom of form that 3D printing makes possible, creating structures that would be incredibly difficult, if not impossible, to achieve using standard construction techniques. Beyond beauty, the bridge is a triumph of engineering. Its 3D printed concrete is specially formulated to be durable and sustainable, with far less material waste than conventional pouring. It was also tested rigorously for strength and safety, ensuring it can handle the daily foot traffic of residents and tourists alike. This project is more than just a bridge, it's a statement. China is showing the world that 3D printing isn't confined to small-scale experiments. From entire parks to working infrastructure like this bridge, the country is proving that cities of the future may quite literally be printed into existence. Anji Culture and Art Center, floating roofs and sustainable design. The Anji Culture and Art Center looks like something out of science fiction, but it's rising today in Zhejiang Province, China. Designed to reflect Anji's identity as the hometown of bamboo, the center's most striking feature will be its enormous bamboo leaf-shaped roofs. These sweeping canopies, built from shimmering white metal panels, appear to float effortlessly above the complex, creating a futuristic silhouette while echoing the natural landscape. But this isn't just about looks. The architecture is infused with sustainability at every level. The roofs will channel rainwater into an innovative recycling system that passively cools the building, reducing the need for energy-intensive air conditioning. Its open, airy design also maximizes natural ventilation and daylight, making the space as environmentally efficient as it is beautiful. Spanning more than 1.29 million square feet, the center will host theaters, art galleries, libraries, and cultural exhibition spaces, all under one roof. The scale is immense, but the design feels light and organic, as though nature itself shaped the structure. Set to open this year, the Anji Culture and Art Center will be more than a landmark. It's poised to become a symbol of how modern China fuses cultural heritage, ecological responsibility, and cutting-edge technology into breathtaking works of architecture. Phoenix Towers, green energy giants in the sky. Planned for Wuhan, the Phoenix Towers aren't just tall, they're meant to redefine what skyscrapers can be. If completed, the tallest of the two towers will soar to an astonishing 3,300 feet, making it the second tallest man-made structure Earth, taller than anything in New York, Hong Kong, or even Shanghai's own skyline. But the project is about more than just breaking records. Rising from an artificial island in the middle of a 7-hectare lake, the towers take inspiration from Chinese culture. One tower represents the male phoenix, Feng, the other the female, Huang, symbols of rebirth, harmony, and balance. Together, they form an architectural statement blending tradition with ultra-modern design. The technology planned for the towers reads like science fiction. Their facades will be wrapped in solar panels, while integrated systems will harvest wind energy, thermal energy, and even clean power from biomass boilers and hydrogen fuel cells. One tower is set to house the world's highest vertical garden, bringing entire ecosystems into the sky and creating a living symbol of sustainability. Far from being just monuments to excess, the Phoenix Towers aim to become self-sustaining eco-cities in the sky, filtering polluted water from the lake, producing renewable energy, and reducing Wuhan's carbon footprint. If built, they would stand as one of the boldest fusions of culture, technology, and sustainability anywhere in the world. Proof that China can push limits that make even Dubai take notice. Sponge City Landscaping, Nature as Urban Infrastructure. China is rethinking how cities interact with water, and the transformation is stunning. Instead of treating rainwater as a nuisance to be drained away, The sponge city concept designs urban landscapes to absorb, store, and reuse it. Picture walking through a city where sidewalks are made of permeable materials that let water seep into the soil, where rain gardens capture stormwater and filter it naturally, and where green roofs, wetlands, and sunken plazas double as water reservoirs during heavy rains. This network doesn't just reduce flooding, it recharges groundwater, improves air quality, lowers urban temperatures, and creates habitats for birds, fish, and pollinators. Projects like Kunli Stormwater Park in Harbin, the Lingang Sponge City Zone in Shanghai, and the Zhuhai Hengqin Free Trade Zone show how effective the idea can be. In Kunli Park, for example, lakes and wetlands act as giant sponges, preventing floods while providing recreational space. In Shanghai, the Lingang Zone's permeable roads and bioswales make the city resilient against typhoons and heavy rains. The results are cities that feel alive, where infrastructure isn't just concrete and steel, but living systems that protect people while working in harmony with nature. In China's new vision of urban planning, nature is no longer decoration, it's critical infrastructure. Dalian Jinzhuwan Airport, an entire island for an airport. You might think other countries have China beat in airport design, but the new Dalian Jinzhuwan International Airport is in a league of its own. What makes it so unique? It's not being built on the mainland, or even on an existing island. Instead, China is constructing an entirely new man-made island in the Bohai Sea just to house it. The project began in 2011 and is one of the most ambitious land reclamation efforts in the world. By the time it opens in 2026, the airport will cover more than 21 square kilometers, making it the largest offshore airport ever built. To withstand waves, typhoons, and rising sea levels, engineers are reinforcing the reclaimed land with millions of tons of rock and sand. Once complete, the airport will feature 4 runways and 2 massive terminals, able to handle around 70 million passengers and 1 million tons of cargo every year. Its offshore location also helps reduce noise pollution for city residents while freeing up valuable land on the mainland. This isn't just an airport, it's a floating mega-project, proving once again how far China is willing to push engineering to reshape the future of travel. Yangkou 3D Printed Dam, AI Building the Future. High on the Tibetan Plateau, China is attempting something that sounds closer to science fiction than engineering, a 590-foot-tall hydroelectric dam that will be built entirely through 3D printing and artificial intelligence. Instead of human crews laying concrete, giant construction printers will methodically stack the dam layer by layer, just like a desktop 3D printer, only on a monumental scale. But the real game changer is how it's being built. Every single machine on site, cranes, trucks, bulldozers, and pavers, will be fully autonomous, coordinated by AI into a seamless robotic workforce. There will be no human operators, no scheduling conflicts, and no risk of accidents from human error. Think of it as the world's first fully automated mega-project. Even more astonishing is the timeline. While traditional dams of this size can take a decade or more to finish, the Yangkou Dam is expected to be completed in less than 2 years. Once finished, it will generate massive amounts of clean hydroelectric power, showcasing a future where AI-driven construction can deliver safer, faster, and more efficient infrastructure. If successful, the Yangkou Dam won't just power millions of homes, it could redefine how humanity builds the next generation of megastructures. Modular assembly, buildings like giant Lego sets. China is taking modular construction to an entirely new level. You might remember their jaw-dropping mini Sky City skyscraper, which rose 57 stories tall in just 19 days. But that was only a glimpse of what's coming. Across the country, entire industries are now dedicated to modular building, covering everything from towering high-rises and massive stadiums to sleek bridges and modern residential homes. The idea is simple but revolutionary. Instead of building everything on site from scratch, structures are prefabricated in factories, then transported and assembled piece by piece, like giant Lego blocks or a giant life-size puzzle. And the results are stunning. Today, you can literally order a complete home, have it shipped to your plot, and see it assembled in a single day. Even large multi-room houses can be completed in just a week or two, far faster than traditional construction and at a fraction of the cost. These modular homes aren't temporary either. They're designed to be durable, earthquake-resistant, and energy efficient, rivaling and often surpassing conventional builds. With speed, affordability, and sustainability on its side, modular assembly isn't just a trend, it's quickly becoming the future blueprint for how cities will rise. Self-climbing formwork, buildings that build themselves. At first glance, it might look like a strange machine crawling up the side of a skyscraper. But what you're seeing is the self-climbing formwork system, one of the smartest innovations in modern construction. It works like a giant hydraulic mold that grips the building and steadily climbs upward, floor by floor. After one level of concrete is poured and cured, the entire system lifts itself up to begin the next, eliminating the need for cranes to constantly move molds. The benefits are enormous: faster construction, greater efficiency, and less downtime, especially for tall buildings with repeating layouts like residential towers, offices, and hotels. Watching these robotic frameworks scale a skyscraper as they build it is both surreal and captivating, a powerful reminder of how human ingenuity is redefining the future of construction. Super high-speed rail track laying, 2 kilometers a day. China's high-speed rail network is already the largest in the world, stretching tens of thousands of kilometers, and it's still growing at record speed. The secret behind this rapid expansion isn't just manpower, but automation on a massive scale. At the heart of this is the super high-speed rail track laying system, a fully integrated chain of AI-controlled machines. These include rail sorters, push roller recovery vehicles, tractors, and precision alignment systems, all working together like pieces of a moving factory. Each machine handles a specific task, delivering concrete sleepers, positioning rails, laying ballast, and locking everything into place with minimal human involvement. Currently, this system can lay about 2 kilometers of track per day, already far faster than traditional methods. But the vision is even bolder: to achieve continuous 24/7 automation, where trains of machines can construct railways around the clock without rest. If successful, future high-speed lines could be built at a pace never seen before, drastically cutting down both construction time and cost. For a country where rail is the backbone of travel and trade, this level of automation isn't just convenient, it could reshape global standards for infrastructure building. Tunnel boring machines, giants beneath the earth. China's tunnel boring machines, TBMs, aren't just big, they're record-breaking giants of engineering. Some stretch over 100 meters in length and weigh thousands of tons, capable of carving out multi-lane highway tunnels, metro systems, and rail corridors in a single continuous operation. Designed for China's complex and often unpredictable geology, these TBMs can cut through everything from soft clay to solid granite, all while reinforcing the tunnel walls as they go. Many are modular in design, allowing them to be disassembled, transported in pieces, and reassembled deep underground or in remote regions. What really sets them apart is the integration of AI-driven navigation and monitoring systems. Sensors track ground pressure, cutter wear, and alignment in real time, while AI adjusts operations to maintain precision and prevent collapses. This means safer work environments, fewer delays, and a drastic reduction in accidents compared to traditional blasting methods. The payoff is enormous. Tunnels that once took decades can now be completed in just a few years. With these machines, China has surged ahead as a global leader in tunnel construction, tackling mega projects like cross-sea tunnels, deep mountain passages, and sprawling metro networks at a scale no other country has matched. Drone-assisted material transport, flying construction crews. China has found inventive ways to integrate drones into large-scale construction, pushing the technology well beyond its common roles in agriculture, firefighting, or surveillance. On construction sites, drones are now delivering critical building materials, such as solar panels, steel cables, and prefabricated components, across rugged or hard-to-reach terrain where cranes and trucks struggle to operate. Specialized heavy-lift drones, some capable of carrying payloads of several hundred kilograms, can hoist supplies directly to the upper floors of skyscrapers or across valleys, slashing both labor costs and construction time. One striking example came from a bridge megaproject in southwest China, where drones were used to string the first pilot cables across a deep gorge. Traditionally, this would require workers climbing precarious towers or sending boats and helicopters into dangerous terrain. With drones, the process became not only faster and cheaper, but also far safer, removing human risk entirely. As the technology advances, China is envisioning fleets of autonomous drones operating like airborne logistics crews, building faster, safer, and higher than ever before. Rotating bridge deck construction, no road closures required. While many countries shut down roads for days, or even weeks, during bridge construction, China has mastered a technique that keeps traffic flowing almost without interruption. Instead of building directly above busy highways or rail lines, engineers construct entire bridges alongside the road, often on temporary supports. Once complete, massive hydraulic pivot systems swing the bridge into position, rotating thousands of tons of concrete and steel with millimeter precision. In some cases, the process takes just a few hours, with motorists driving by as if nothing unusual is happening. This approach not only saves time and reduces traffic chaos, but it also minimizes safety risks for both workers and commuters. Recent projects have seen bridges weighing more than 20,000 tons rotated and set in place overnight, a feat of coordination and engineering power that has become almost routine in China. It's a striking example of how smart construction methods can deliver speed, safety, and efficiency all at once, turning what would normally be weeks of disruption into a seamless overnight transformation. Robotic bricklaying, perfect walls every time. AI-powered bricklaying robots have already become a regular sight on Chinese construction sites. Unlike human workers, they never tire, never take breaks, and can lay bricks with millimeter-level precision. Guided by computer vision and laser positioning, these robots pick, align, and place bricks in perfect sequence, even applying mortar automatically as they go. The result? Walls that rise at up to 10 times the speed of traditional methods, with quality that's consistent from the first brick to the last. These machines can also work through the night and in harsh weather, keeping projects moving when human crews might have to stop. Some advanced versions are even semi-autonomous, capable of reading digital blueprints directly, adjusting for angles, curves, or complex layouts without extra programming. For developers, this means lower labor costs, faster timelines, and fewer errors. While bricklaying might seem simple, China's robotic approach shows how even the most basic construction task can be transformed by AI and automation. Robotic plastering, smooth walls in minutes. To complement automated bricklaying, China has also introduced plastering robots that can smooth, coat, and level walls in just minutes. Equipped with precision sensors and adjustable nozzles, these machines spray plaster evenly across large surfaces and then flatten it to a uniform finish, work that would normally take a team of laborers hours to complete. While they haven't completely replaced human plasterers yet, they dramatically cut down on time, reduce material waste, and deliver flawless consistency on every wall. Some newer models can even map a room digitally and adjust their work in real time, ensuring no uneven edges or missed spots. Together with bricklaying robots, plastering robots mark a major step toward fully automated construction sites, where machines handle repetitive, labor-intensive tasks, leaving humans to focus on supervision, design, and problem-solving. Self-healing concrete, buildings that repair themselves. China is also embracing self-healing concrete, a breakthrough material that quite literally repairs itself. The secret lies in special strains of bacteria mixed into the concrete. When cracks form and water seeps in, the dormant bacteria wake up and begin producing calcium carbonate, the same substance found in seashells, which fills and seals the gaps naturally. This innovation is already being put to the test on the Shanghai Highway, where it helps prevent cracks from spreading into potholes, slashing repair costs, and reducing traffic disruptions. Beyond highways, it's also being applied to bridges, pavements, tunnels, and high-rise buildings, giving structures longer lifespans and improving overall safety. If adopted on a large scale, self-healing concrete could transform infrastructure maintenance worldwide, keeping cities stronger, roads smoother, and bridges safer, all without constant human intervention.